So inheritance, okay, inheritance it will enable or inherit all the methods and properties from another class. Okay. So that is the basic concepts of inheritance in Python. Okay. So we can use the methods and properties or variables of another class in our class. Okay. So we have seen different types. First one, single inheritance, multiple inheritance, multi-level inheritance, hybrid inheritance, hierarchical. Okay. So single inheritance is nothing but we have only one parent class and one child class. This is parent, this is child. So here we could try the Python code. Okay, class is the class word. Just use it to create a class, and this is the class name. So now this is the method that I have used inside this class. Okay, so if I want to use this method, I have to create one object. For example, object equal to here I have created it for child class, but we can create, usually we will create for object, we have to create it for accessing the variables and methods for the class, right? So using this inheritance property, if I have created the object for this child class, then also I can access the parent class, okay, using the object. So you could see here object is created for child class and using the same object function one is called. This function is already present in the parent class, but I have used the object of child class to call this method. Okay. But I could call it and I can able to access this one. Okay. So next, same object and whatever methods that are defined inside the class is also visible for this object. And because of this inherited, okay, so we have passed the parent class into the child class. So the functions which are defined inside the parent class also can be used using this child object. Okay, this is the first type of inheritance. Okay, so single inheritance means it has only one number of child and it has only one number of parent class. So it enables the derived. Here derived is nothing but child class to inherit properties from a single parent class. So why we need to go with this inheritance concept means it enables the code reusability, and if I want to add any other features, I can reuse these functions again. Okay, I no need to create the same function inside the child class. Okay, so I no need to create the same thing. So I can reuse the same code. Okay, using this inheritance. But if you are not going with this inheritance, you cannot access this one. For this, you have to create one object, and for child for another class, you have to create another class. If we are not following this inheritance property or implementations, okay. So multiple inheritance when a class, okay. So this is the derived class, okay. So there we have derived class, and derived class will be derived from the parent class and single parent class. And this is multiple inheritance, so that the derived class is nothing but child class, okay. So this derived class from more than one base class. This is base class 1 or parent class 1. This is parent class 2. So the derived class can be derived from more than one base class or parent class is called as multiple inheritance. So consider this is parent class 1, this is parent class 2. Now I have created one derived class which is called as son. Okay, this class is derived from both of the parent. So I have to pass this as the argument for this classes. So mother and then father. So now using this object of son class, I can able to call this method father and I can able to call this mother also using the son object. So S1, this is the object name that was created for this son class. Now using the same object, I can call, okay, I can call the methods also. So here it will just print the mother name and father name. Okay. So this is the job of this method. But you can do your you can code it. Okay, your own problem you can use it here. Okay, this is one example. Okay, so class first, class second, class third. So we are just deriving third class, okay, from first class and then second class. So it comes under multiple inheritance because we are deriving the class from more than one parent class. So pass this first and second. And if you want to do some, if you want to define any other function, you can define it in this third class. Otherwise, you can go with this pass statement. Okay. So object one is the object that was created for the third, that is the derived class, and then print object one. This is the object that we have created for the third class. Now I can able to call this function because this function is inside the first class, but still I can call this one. Okay, someone now pass A and B, it will return C. So 20 plus 25, 45, right? And second, again we have sub 1, okay, that will do the subtraction. Okay. So if you pass it, it will return the subtraction of 50 minus 25, 25. So what is the output now? 45 is the first output of this print statement. Second one, subtraction 25. So what we did here, we have created one object for the son class. Using that object, we are just calling these functions which are in the base class or parent class. So that's why we can reuse the same code. Okay. Third types of inheritance is multi-level. So here the derived class, okay, in multi-level inheritance, the features of the base class and the derived class. So this is the methods variables in this base class, and this is the methods functions in the derived class are further inherited into the new derived class. So this is new derived class. So base class, derived class, newly derived class. So we can have n number of classes or intermediate classes. Okay, base class, intermediate class 1, 2, 3, 4, and finally you can have derived class. So if you come like that, it comes under this multi-level inheritance. So same example. So first class will do the addition. Second class, okay. So some print statement is written here, and then third class some other function is written here. You can define your own function here. So how we are passing the arguments? So this is the base class, okay. This is the derived class. So derived means you have to pass the parent class to this derived class. So now parent is first. So pass this. So second and then first. Okay. Now I will be having third class. This is the newly derived class and you pass this here. Okay. So you could see the difference between the multiple and multi-level. So now same thing, I can create object for this newly derived classes. and I'm just trying to call this function. This is the base class function, right? So using this object, I can call this one. So it will just do the addition, but it will get the oh. Okay, this is another example of multiple. So this is base class. Okay, so here grandfather is the base class, and here we have the init function, that is the constructor. Okay, it initializes the values. Next, we will be having another class which is called as father, and father inherit the base class, that is grandfather class. And here also we will be having one functions invoking constructor of grandfather class. Okay, next derived class. So this is the final derived class. So father has to be passed as the argument, and then grandfather. So it will do the initialization son name. Okay, and we have the uh, one print name method. Okay, so just use it to print the father name, father, grandfather name, son name. Okay, so now this is the object that was created for the son class. Okay, son class. And now I for this son class. Okay, for this son class, I have to pass the three arguments: son name, father name, grandfather name. So once the object is created, it initializes the values. And if you want to print s1 dot grandfather name, so the grandfather name is will be printed. Okay, printed. Okay, so it will print the grandfather name. Next type is hierarchical inheritance. So here, when more than one derived classes are created from a single base, this type of inheritance is called hierarchical inheritance. So previously, we have seen the last derived class, it has only one class, that is called as derived class. Now, instead of one classes, if we have more than one derived classes, okay. So more than one derived classes, all these derived classes are derived from one single class, single parent class. When more than one derived class are created from a single base class. So this is the single base class, and we have more than one derived class. So consider this example. So here we need one base class and more than one derived class. So class parent, so function is defined here, derived class 1, and this is base class only, you have to pass to the other child class. So parent is passed, again child 2, this is the second derived class, and same base class. You could see same base class has to be passed as the argument. So anyway, this object has to be created for the last derived classes child 2, and here object 1, 2 are created for child 1 class, child 2 class. So for child 1 class, because previously we have only one child class, so we have created one object. Using that object we can access it. But here child 1, it inherits property of parent class. Okay, so if you created this object 1, you can use this functions. But for this child 2, okay, you want to access this one, you have to create object, and if you want to access this one, same object can be used for this. So object 2 equal to child 2. So second object is created. For first object, function 1. Okay, so this function can be used because this is the base class, right? Object 1 dot function 2. So this is already defined inside the class, so it can access. Now object 2 also it can use this function 1 and it can use this function. But this functions which are inside this child 1 cannot be passed because we are not passing this to this one. So next, hybrid inheritance. Okay, so hybrid inheritance is nothing but the inheritance consisting of multiples of inheritance. Okay, so for example, so you have one base class and it is derived from, it has two derived class. From the two derived class, we are just creating one class. So it has multiple classes. Okay, so A B is inheriting properties of A. Okay, so that is A, and here A we are derived the B. Okay, and C is also derived from A. So that is like this. C is also derived from A, and then class D. Okay, so D is derived from B and C. Okay, so your flows goes like that. So we have one functions in A, we have functions in B, so we have functions in C. C is also A is derived, and then D, B and C is inherited. So we could use any all the functions inside it, right? So now object is created for D class, right? So where is D? D is here and it can access B and C. So in B and C, A is also can be accessed. So all these functions can be accessed using this if you created object of this D class. So object 1 dot M. You could see here M is defined in all the classes, same functions or same method. Okay. So first it has created for this D class. So it will check here M from class D. So that is the first line. And B dot M self. So it goes to B and M is from class B will print. Again C dot M self. So now it goes to C class and M is there from B class. Okay, and A dot M. Now it goes to M from class A. So those are the output of this hybrid. Same thing, school. Okay, student 1, school is inherited, and student 2, this school is also same, school is also inherited. Okay, so that is we have school, we have school. School 1 is inherited from this, yes. Okay, and S2, we have another S2 derived class. It is derived from the same school class. And we have student 3. Okay, consider this is student 3. And student 1. So student 1 and student 2. Okay, so we could write student 2. So here it should come. So we can change this one as student 3 also. Okay. So now object is created for student 3 and object dot of function 1. Okay. So here I can call this one because the school is derived. This S1 is derived from S3 is derived from S1. So I can use the method which are in the school also. Okay. So we call the this function is in school, and again function 2, same object function 2. Okay. This function is in student. So you will get the output. Okay, with this you can create types of inheritance, and each types will vary based on the number of classes that you have used, number of base class, and then number of child class.